Arkadi.
Hi, Peter.
Welcome back to the technology quiz, the challenge that is fully unprepared.
I'm completely unprepared and I'm very excited and happy to be with you again.
Yeah, it's my turn to challenge you today, and I have prepared something that I had no idea of myself until in 2023. I was reviewing a paper for a conference, and when I received this paper, I said, "Why are they working on that material? Because this material is obsolete." But then I read the paper and said, "Wow, I had no idea that this was possible." So this is the
Okay.
quiz today. I will share my screen so you can see the quiz. Whoop.
Now I see all the pages, so I close my eyes.
Yeah,
Not to
good
look.
idea. It doesn't work. Oh, it starts in the middle. There we are. Now you can see.
Okay.
Yeah, it would not allow me to push the button. We are today going to talk about a metal. And
I mean, heavy metal.
yes, and you have to guess which metal. But when you have it, just say yes, I have it. Don't say it, because the idea is that you can see there's 6 points available. If you get it on the first, then you get 6 points. And I would like the audience to be able to guess as well. So we will disclose what you had at the end, and then the audience can also guess with you. So what metal do you think it is?
So 6 points just looking that it's heavy metal. So that means if it's a heavy metal, it's something like refractory. I don't know. We can think in that direction.
You have
Recently, I had a lot of to do with niobium, hafnium, zirconium. So this is like a heavy metals like tungsten, molybdenum.
yeah. I will not say anything. I'll go to the next information.
Okay.
Yeah. Do you know what this is?
No.
No. It is an acceptance criteria. If you buy a product in China, you want it to be free of some substances.
Okay. This is this metal safety data sheet to pass not to be harmful for health or something like this.
Yes.
Restriction of hazard. Okay. Now I know what it is. Yeah.
Yeah.
Okay. Yeah.
Yeah. Should we take next information?
So should I get?
Yeah, the
Can
density.
Can I
of
open the periodic table?
Yeah. Do you know what metal it is now?
Uh,
A density 11.35.
Let me think what this might be heavy metals. No, let me give me one more clue.
Yeah, you get one more. Melting point, 328 degree.
Okay, then it's easy.
Yeah, it's easy now.
Yeah, it's
Yeah. Or yeah, you get one more information. Do you see what it is?
No, this is a it's accumulator.
Yes.
Okay. So melting point 320. What was this melting point? Was it magnesium? Oh. Okay, give me one more clue.
You get the final.
Okay, I know what it is, but
Yes.
I don't know how is it called in English.
What would you call it?
I know this is used for fishing, so yes, so
Yes. Yeah.
it's a very long, so but it's not clear. Okay, yeah.
Yeah, it
What was
is.
this? What was the name of it?
The Latin word is plumbum.
Yeah, Bloom, exactly.
Yeah.
Okay,
And the English word is lead.
lead, exactly, lead.
Yes. So
That was
we are going to
bad
look
from
into
my side.
lead today.
Okay,
Yeah. Do you know some applications where lead is used?
except fishing?
Yeah, fishing.
No, I don't. Give
Mm.
me a sign.
Yeah, there are a lot of application. It's used in construction, for roofs.
But
Yeah,
okay, I saw what maybe it's used a little bit in batteries, but otherwise you would not
yes,
show it on the last
yeah,
page
yeah,
example.
batteries. Yeah,
Yeah.
yeah,
Okay. Bullets.
bullets. If you want to kill somebody,
Yeah.
fill them
Okay.
up with lead. Yeah.
Radiation surely. Interesting.
Yeah, weights for fishing, soldering, and the soldering, that's the main issue when you buy some electronics and you want it to be lead free.
Mhm.
Yeah, fusible alloys, even paint. And then when I was a kid, all the gasoline was leaded. And today we still have a lot of lead along our highways and roads, because all the lead that came out of the exhaust pipes of the cars are still there. And
But is it not toxic?
it is toxic, yeah. And then radiation shielding. If you have been at the dentist and getting an X-ray, they put
You get protection. Yeah, exactly.
yeah, they put
So
protection on.
I never knew this, but the protection from lead.
Mhm.
Interesting.
Yeah. So why is lead a problem? And you
Toxic.
said it already. It's toxic. It's
Give,
neurotoxic.
give me back my 6 points.
Yeah, you get it.
Okay, thanks.
This is 10 points. You answered even before I asked the question.
Okay.
Yeah.
So
Yeah.
toxic in the lab. Yeah.
Yeah.
Okay, neurologic disorders.
Yeah,
Okay.
it's pretty harmful, as you can see here. It can damage your brain, your ability to learn, your ability to speak and behave well, your ability to listen and hear. It can be bad for your blood pressure, your blood cancer, reduced growth. And in fact, in the old Roman Empire, that was some people, they claim that the Roman Empire went down due to lead toxicity, because all the pipes to bring in drinking water to the houses, they were made in lead. So people were lead toxic in the entire Roman Empire. And today, when they test the bones from the graves, they can see the bones are shorter. So there has been reduced growth in the people, and they can measure that the lead concentration in the bone is 10 to 50 times higher than it is in non-toxic people.
Crazy.
Yeah, so they, in fact, they lead took down the Roman Empire. Is the conclusion.
So that this will not, okay.
Yeah.
Okay, good.
So now we jump into why I took this up, because I thought lead was dead. I grew up my entire life being taught that lead has to be stopped. Don't use it. So when I read this paper from it was from Madrid University, working with liquid lead in such a machine.
Okay.
It was called a lead fast reactor. Do you know what that is?
Like a kind of turbine?
Yeah, the product out here, it's a turbine. But the lead is in here.
So it's like heat generation?
A lot of heat. Because what is going on in there is a fission reaction.
Mm-hmm.
It's a fourth generation nuclear power plant. Today, a standard reactor is made with water in it,
Yeah,
and
okay,
sometimes
the hard water.
yeah, the heavy water, and
Or heavy water, yeah.
yeah, and you transfer the heat from the reaction of the uranium. You transfer that to the water, and that is then boiled and heat transferred in a heat exchanger up here.
Mm-hmm.
But here they exchange the water to liquid lead. Why should they do that? Do you have some ideas on why that is an advantage?
Compared to water.
Yeah, to get rid of the water.
Yeah. Okay, because the heavy water is not disappearing. It's actually as also called dead water, and it actually causes you a lot of sustainable damages. But okay, high boiling point.
Yeah.
So it
That
gives you
is
an addition because the heavy water also get radiated. Yeah, so this one can protect you from radiation.
yeah, that's right. The lead itself is a strong shielding from radiation, so you don't need such a big shielding around it. So you can build it smaller and still be close to it. But the main advantage is that lead has a boiling point pretty high. So you can run this in a very big span of operation without having any high pressures. When you have water in it and you boil the water in such a vessel, you have a high pressure. So if you have to build this into a pressure tank, a pressure tank is crafty and heavy and expensive and difficult to build, and there's high risk when you have high pressure. But when having liquid lead, you can run everything at 1 bar and still have heat transfer here, and in the tubes in the heat exchanger you can produce the steam that runs the turbine and make the heat exchanging at 550 or 600 degrees C.
Okay, but you still need to ensure that the lead is in the liquid phase.
Yeah,
So
lead has to be liquid.
So it means you need a protective walls working in operational temperatures around 400 Celsius.
Yeah, you already get 10 points more on the next slide.
Okay, sorry, I'm running. Now, now I feel my ground. Where I say, how we protect everything against the liquid lead. Okay, good. Yeah.
So the the biggest advantage is the high boiling point, because in a normal water-based reactor, you have a very high pressure because you're boiling the water. And in order to transfer the heat, you need to have that built into a pressure vessel tank.
Yeah, so I think what is my concern here, Peter, is that you need to operate this at the temperatures exceeding melting point of lead, which is
Yes.
what you showed before, 323 Celsius or 21. So
Yep.
it means you operate around 400 Celsius.
Yeah, at least.
How we protect the chamber? Corrosion.
Yeah, that's
High temperature corrosion.
that's next issue. It's the next slide, and but you'll get 10 points on the next slide already.
Okay, thanks.
But the big advantage is that you can run everything here in one bar.
It's
And
this what I understood, that is actually really low pressure, and this is amazing. Yeah.
yeah.
And
So-
what I also like, this is an argument about the radiation shield. Just shield. Sorry.
yes,
So
it's very good radiation in itself. So you don't need such a big wall of concrete around it to protect you from radiation.
because you know what, maybe a comment here, I might be wrong. Remember when we had this catastrophe with Fukushima in Japan, and then they were using a water and heavy water to cool the reactor down, yeah, to ensure that we don't get this catastrophe continuously.
Yeah.
And the biggest question is, where do they link this water back to? Because the water is regulated. Nobody was really telling a lot of truth about that.
Yeah, the water in that case started to boil, and when the pressure was too high, it exploded. So in fact, that was the reason for the spreading of radioactive material. That was that the water boiled. So in the case of this system, to reach this temperature, it's pretty difficult. So the risk of having an explosion due to boiling in a lead base is a lot lower. But of course, you are right, because if we look into some of the obstacles for this to succeed, you already said, what about keeping at these temperatures? How should you build such a chamber? And you also want to pump it. So pumping it.
Yeah, so corrosion. What I also think might be an argument. If I remember the very first slide and what we started with, lead is heavy.
Yes. So pumping it is also difficult.
I suppose so.
Yeah. And that also causes some problems with erosion on the pump systems. But the funny thing here is when we look at corrosion, what I thought was a low alloy material, a standard ferritic with only 8 to 10% chrome, seems good. Where a high austenitic grade with a lot of nickel can cause problems because nickel will be dissolved into the eutectic system of lead bismuth. And the paper that I referred to, they were in fact looking into developing a ferritic system containing aluminium. And the aluminium would go to the surface and protect the surface layer with an oxide film. So there are people developing new materials for these kind of applications out there.
I have actually a very good material which we recently developed, also ferritic material. high strength, high temperature material, but to be used as a hard facing, for example.
Yeah.
On certain areas. It might be interesting to dig that. Okay.
Yeah. But to test it in liquid lead it's different. And then you were right. These were your first 10 points.
Yeah.
You said, yeah, you have to be running at 400 degrees to avoid it from freezing. And yeah, and because the melting point was 328. So this is absolutely vital for the system to survive. Then no oxygen is allowed, because if you form oxides, lead oxide has a melting point of 888 degrees. So lead oxide will form particles that will float around, and it can clog in pumps and in tubes. So it is very important to keep oxygen out of the system.
Which is not easy.
Yeah.
Or it's just a cost factor, probably, what is it?
It's after sealing it, lead or the oxide has to be kept outside. And then the final one, you also said lead is heavy. So pumping it gives a lot of erosion on the impeller blades. So there will be some wear, and maintenance is pretty difficult inside such a chamber. Yep.
Which is basically a tribological topic.
Yeah, you're right. Yeah, referring to our last challenge on tribology.
Not only, I mean, like, from my opinion, hard-facing technologies, it's really an attractive solution for this type of applications.
It could
if
easily
you want to have a combination of cost saving and still giving you increased lifetime.
Yeah, and especially on the blades, a coating could be the solution to make a long life on the system. Yeah, and the last, as we talked about, the lead toxicity, to work with this can be damaging for your health. So it has to be sealed away. It has to be taken pretty precautionary when you touch it.
I just have a very provocative idea in my brain. It's like, what is more toxic, radiation or lead toxicity?
I think radiation is a bigger problem than lead toxicity.
Which you basically, again, can keep more under control if you use the hazard protective equipment in an easier way, probably, than radiation.
Yeah. So it seems that the advantages are bigger than the disadvantages. So, do you think this technology exists today, or is it just something that came out of my brain?
I would say, knowing you that you read the papers and you were thinking, remember you gave me a small insight when last time talked, you said they plan to use it. That means I would assume there might be some developments, but it's not yet a running technology.
It's pretty good. In fact, there are Russian facilities where it is installed today. Then in China, they have test facilities. In US, they have test facilities. And there's even private companies working on it. The company Westinghouse, when you look on their homepage, they have, you can buy it. If you want to buy such a, and put it in your garden, you can buy a lead-cooled fast reactor.
Okay, on a small scale, you mean, yeah?
Yes, it's a small-scale reactor.
Is it enough to produce energy for one home? Probably yes.
It could be energy levels 50 to 100 megawatt size typically. So I know that there are a lot of industries now looking into going electrical. So steel plants today they use coke and gas burners. And if you have to transfer a steel plant, transferring the iron ore to steel, my best guess is that you would need something like 500 to 1000 megawatt of electrical power. And that is not available today. There are very few countries where they have this amount of energy in the grid. So therefore, in near future, small plants like this will be locally installed. So a steel plant could have their own fast reactor. And it could be a 100 megawatt reactor supplying their own production.
It doesn't answer the question. Is it already used or it's a testing phase? Like
it is still in test phase. It is not industrially used today.
But this might be a solution for the issues we have now in the European Union with the energy crisis.
Yes, absolutely. And these small reactors has been on the agenda for some years now, and the last thing I heard was that within 3 to 4 years they will be installed industrially. Maybe not a lead based, but it could be another type of generation 4, because there are different topologies. There are also liquid salt reactors burning thorium being developed. So several solutions are in the R&D phase and expected to go into industrial installation within the upcoming years.
I think the key word what you say is generation 4.
Yes.
Because it's probably what gives you faster time to market. If you say 3-4 years, if you will look on standard clean reactor construction in a clean power plant, it's usually 15 to 20 years project.
Yeah.
That might be actually interesting, especially if you focus not on large ones, if you multiply several smaller scale, but I would say for industrial music, like as you say, steel industry or larger companies can have their own reactor under affordable price.
And I think in Switzerland, where you are, there are some pretty large chemical industries where they are also today strongly dependent on gas.
Yeah.
And they cannot transfer to electricity because the grid is not there today. So it could be the solution also for that kind of industries.
That's a very valid point, actually. I like the topic, Peter.
Yeah, I have one more, because we haven't finished with lead yet. I have a last one. This is called lead as a carrier of lithium in the alloy system lithium-17 with lead. It's the architectum you see here.
Yeah.
What is that used for? What and if you look at the picture here, it might give you a clue if you are skilled at reading children's drawings. And this is really the future.
Is it like Okay, so if you see lithium and lead, it means it goes into direction batteries and probably having small engines for, let's say, cars and other applications as a possibility to be avoiding the waste which we currently produce.
It's a lot bigger. It's so big that it's difficult to imagine.
Is it like okay, good job. Yeah.
Yeah, this is the production of tritium.
Okay.
And tritium, do you know what that is?
No.
Hydrogen is made of the hydrogen atom is one proton and one electron. Deuterium is a hydrogen isotope with one proton and one neutron. But tritium is a hydrogen atom with one proton and two neutrons.
Okay.
And they are named here. The D is deuterium. The T is tritium. So in this case, by bombarding lithium-6 with a neutron, you can separate it and produce one helium, and one tritium. So you can see the separation. One helium goes there, one tritium goes there. Tritium then evaporates out of the system because this is in liquid phase, and it can go out. It forms the molecule. It could be the H2 molecule with two tritium, or it could be the H2 molecule with a deuterium and tritium. But what is the purpose of this? Why? What should we use tritium for?
Doing reactors probably again.
Yeah. Oh, that was the reaction going on. Yeah. The tritium is the fuel for our future fusion reactors. And the great thing, the ITER project, where they produce a plasma of tritium and deuterium, and when that is 150 million degree hot, it fuses together, produce a lot of energy. But how should you have this running for years and years? Because you use the tritium, it disappears. So they have invented, they found this alloy to be good as a breathing blanket.
Okay.
So inside the fusion reactor, behind the tungsten walls, they have a blanket of this material. And when the neutrons that are produced in millions in the fusion reactor, when they hit it, the neutrons, they produce new sources of fuel. So as long as the machine is running, fuel is produced. So this is the way to produce the fuel and keep the fusion reactor running for years and years. And recently, I think they broke the record. It was running in France for 22 minutes, producing energy. So we are still a bit far away from having free energy by fusion, but this is one of the methods, and development of lithium lead alloys that fits this system, that produces the right amount of tritium to balance the energy production with the production of number of tritiums it is ongoing these days. So there are really activities in developing lead-based alloys for our future energy production.
But we still use a certain amount of lithium there.
Yes, and the idea here is that when you have it liquid phase, you don't have a layer that you use up. So it's stirred around and new lithium comes up. So you can continue the process for years and years.
So you basically can reuse this lithium all the time.
Yeah, but you're right. You cannot add new lithium while it's running. So hopefully the blanket they put in has lithium enough to run the machine for 50 years. That's the target.
And that's why they're running tests to see. I got it.
Yeah.
I mean, like,
So it's some pretty heavy tests.
I will be honest with you. I'm quite far away from this topic, also chemically. Yeah. But I like the idea.
I was too, and I was so amazed. And then I went into a rabbit hole when I started to dig it up because it was so fascinating that this is going on. It was a sort of metallurgy that I had never heard of before. So so it proves that I have some people who said metallurgy, that is for old men, that nothing new happens. But here we are really on the edge of future development. And I know that a lot of people are needed because the material has not been developed yet. They still need to develop 40 new alloys or materials to make these systems work. So if you are out there and thinking of should metallurgy be something for you to study, yes, it should. There are a lot of tasks to run.
I mean, like there is a saying about metallurgy and generally material science being outdated, but you feel that it's not the truth. I fully agree. Honestly saying, metals especially still are most used materials. Okay, except plastic, yeah. But you cannot fit the reactor with plastics. That would be actually a very cool thing if we could use plastic as a base to feed the reactor to generate energy.
Yeah. So the last slide, Arkadi. This is you cannot answer right or wrong, but what do you think? Do you think lead will play a new role in future technologies and be accepted from the darkness and brought back?
At the end of the day, you gave today a very good example where lead can be used. I mean, like, I personally believe the only future energy source which humanity need to move into direction, which is clean, it's not clean reactors. Just we need to find a way how we can mitigate those risks which can occur by usage of this. But it's definitely, in my opinion, much better energy source than all the wind turbines and solar panels, especially if we talk about large energy product generation. If that would be lead-driven reactors, why not? What I've learned today, I need to deep dive and read, actually made me wish to learn more, which is really, I would say, cool. I also hope that those who listen to our podcast will also try to learn more about lead and usage. I like the idea of lead lithium alloys. Again, I have no technical understanding behind that. I will be very honest.
And I would like to add, all this information is something that I have digged up on my research. I have never worked with it, and there might be some assumptions I have made wrong. And if somebody listening who knows better and could correct me, I would be so happy to get these corrections in the comments on the YouTube channel, because then I can also learn a bit more. I'm here to learn like you are.
It's a good ending words, Peter.
Yeah.
But I really love the idea of the fast reactor.
Yeah. So, Arkadi, we are at the very end now. Do you have a final word? Have you prepared something for me for next challenge?
I would say that today I had almost a knockdown with certain questions. Okay, I got failed at the beginning because I had it my head the name of the film book, but not in English, so I did not know the English word there, unfortunately. So yeah, but at the end of the day, I've learned a lot, and I would say thank you, Peter. Really, it's a great example, and this is actually, in my opinion, should be a topic that we not only discuss and what we both know, but also to learn. And it's going to be like also more opening to, I would say, willingness of people to dive into metallurgy and technologies. I so hope with that. So I will also now prepare something special. So I promise I go away from standard technologies, which I feel myself as an expert, and for next workshop for Greece, I will prepare something where I would also probably start more or less from scratch and that.
Yeah, that'll be great. And remember, some of the best thing today was to have heavy metal.
Yeah, but you know, this is a little bit, let's say, misleading, because yeah, it is heavy. But if I start to think about heavy metals, I go direction refractory ones immediately. Yeah, and it was misleading at the beginning.
Yeah, but I'm a heavy metal fan myself, so therefore I wanted to put that on. Yeah, but Arkadi, let's end here. And if somebody have some ideas on topics that we should take up, what I showed today, I dig that up over the last 2 weeks. So challenge Arkadi or me if you have a topic that you would like us to dig into. We would love to present it the best way we can.
I'm 49 followers away from doing this live, which would be even cooler, that we can do it direct exchange and not recorded.
Perfect. Yeah. So thank you, Arkadi. See you in 2 weeks for the revenge challenge.
Deal.
Yeah.